This is for mathematical methods. It is the Heffernan 2020 exam 2, question number 1. Okay, so we have this function that doesn't have a restricted domain. So I've got it over here, so I might grab it and have a little look at it. And it seems to have one stationary point. Then it's asymptotic. Find the coordinates of that stationary point. So I need it in the exact form, so I will take this and I'll take its derivative. d dx. I don't need to know the derivative, so I'll set it equal to 0 and solve for x straight away. And that tells me that it's at 1. And if I take this and math 3 given x equals that, don't worry about the brackets, and it's 5 on E. And since it's worth 2 marks, I'm going to say f dash of x equals 0, and that will give me my method and will give me the exact. So find the values of x for which it is strictly decreasing. Strictly decreasing, my bound book tells me I have square brackets on the turning points. So strictly decreasing will be from 1 to infinity, because it's got gradients that are negative all through there. So 1 to infinity square bracket. And part C, the average value. So I've got in my formula book a rule for the average value. And the average value is going to between A and B. It's 1 on B minus A, integral from A to B of f of x dx. So the average value in this particular case will be 1 on 5 minus 0 from 0 to 5 of f of x dx. So if I take this, I put it into a new line, and I bring up my keyboard, and I do the integral from 0 to 5 with respect to x. And right at the front, fraction 1 over 5 minus 0 is 5. And there's my answer. It's got to be in this form. So I'm going to take that into a new line, and I'm going to transform, expand, and there's the form that I'm looking for, which is 1 minus 6 e to the minus 5, or 1 minus 6 on e to the 5, and it's telling me to write a, b, and c, so a must equal 1, b must equal 6 because the negative is already there, and c equals 5. Okay, part D, let the function t represent the tan line, so t equals at x equals 4. So I take my expression and I copy it, and I select it, interactive calculation line, tan line at x equals 4. And that's my expression. So it's going to be minus 15x e to the minus 4, minus 15x on e to the 4, plus 80 on e to the 4. Beautiful. Find the values for x for which t of x is bigger than f of x. Okay, I've got a graph there of f of x. If I look for t of x, I can see that t of x is below f of x, equal, below. It's only over here that t of x is bigger. So if I do analysis, G-solve intersection, first intersection point is x equals that. I've got to do it to 4 decimal places. So I'm minus infinity all the way up to 0.4065 and not inclusive because I want t of x bigger. And that's the only values where the red straight line is bigger than the blue tangent line. And then if I go to E, find the values of D for which I've got to move it sideways. has exactly 1. So I might just go and clear all, okay, grab my line again. So I've got an x-intercept of 0. So at the moment, when d equals 0, that hasn't moved anywhere, there is no positive solution. Therefore, for there to be a positive solution, this graph's got to go that way, which means d's got to be negative, so d's got to be less than 0, or d is an element of minus infinity up to 0, but not inclusive. For example, if I moved it 1 unit to the right, so if I have this, and I go interactive define as f of x, and then I take f of x minus 1, and I graph that, I should have one positive solution, and I do. If I had minus 2, I would still have one positive solution, which I do. If d was positive, however, like plus 1, I only have one solution, and it's going to be negative, so d had to be negative. So find the values of h. Okay, so now h moves it up and down, and I'm looking for 2 solutions. So where is f of x minus h equal to 0? So where does f of x equal h? Gives me 2 solutions. Okay, so if I clear all that, and I grab this again, so at the moment, h is 0, and I only have one solution, it's at the origin. So I'd like to know what the analysis G-solve of the maximum is. It's at 1 and 1.83, 1.84. Sorry. 1 and 1.84. So if I move it up, I'm going to have 2 solutions for all of these values of h between 0 and 1.84. How many decimal places am I looking for? Find the values has to be exact. So I know the value because it happens to be the turning point. So it's 5 on E. So h can go from 0 to 5 on E. When it's equal to 5 on E, there's only going to be one solution. So they're the values of h that I'm looking for.